second graders. Today we are doing Module 7, Lesson 25. We are going to keep working with line plots. Today we are going to learn how to draw a line plot and then use that line plot to help us answer questions, and then also do what's called draw conclusions, where we figure things out based on what the data is telling us. The first thing we're going to do, though, for a warm-up is we're going to do a decomposition tree. So grab just a piece of paper, and you know how to do it, where it can be a blank piece of paper. We're going to be decomposing 36 inches into two parts. So get your piece of paper ready. And so, for example, I might say 30 inches and 6 inches. So we're just going to keep breaking it down. I want you to get somebody, or you set a timer for 3 minutes and work on this. So pause me, and then when your 3 minutes are up, come back and we'll do the next part of the lesson. Okay, so you're back, ready for the next part of the lesson. So today we're going to talk about making line plots again from data, and there's a couple of other things I wanted to talk about when you're creating your line plot. All right, the first thing we want to do when we create a line plot is we want to look at the data, and we want to look at like the range of the data. So for example, I have a table here in front of me that is like the height of bean plants. So I'm gonna just create this table real quick on my paper. The height of the bean plant, and the number of students. And I know you're thinking, how do those two things go together? Well, the scenario is that the students in Mr. Shields' science class are growing bean plants. So after 5 days, they measured the height. They each had a bean plant, and they each measured the height of their bean plant in centimeters. And so this tells you the height that the bean plants were and the number of students whose plants were that height. I'm going to grab something else to write with because my pen doesn't want to cooperate. Okay, so the first thing I see on here is 9 centimeters. And one student had that data. Then there was 11 centimeters. And 4 students had that. Then there was 12 centimeters, and 6 students had that. Then there was 13 centimeters, and 7 students had that. And you do not need to be copying all of this down, I just realized. Then there was 14 centimeters, and 5 students had that. And finally, 15 centimeters, and 3 students had plants that measured that long. All right, so I had to get this table created so I can show you what we're going to do. So when you start to think about your line plot, and I'm going to go ahead and draw mine right here, you want to think about what is my smallest number. And at least on this data table here, 9 is the smallest height of the bean plants. Oh, which brings me to another point. We need to always give your line plot a title. So the title of this line plot is going to be the height of the bean plants. Okay, now our shortest bean plant was 9 centimeters. Now here's the thing. We know then that we don't need our numbers. We don't need to start putting X's on our line plot until we get to 9 centimeters. So if 0 is here, I'm going to draw 2 slash marks here to show that we've skipped a whole bunch of numbers before we got to 9. Okay, and so when you see that on some of your papers, you think, what is that? That means that there's a whole bunch of numbers we skipped before we got to 9, because 9 is where we knew we were going to have to start plotting data. Now, this is also a very important thing here. just like yesterday where we put numbers on our line plot where there wasn't any data because they were holding spaces in between, we're going to do that again. So you'll see, look, there is no 10 centimeter plant, but we're not just going to go straight to 11 centimeters. Then there's 11, 12, 13, 14, 15. So we need to leave that space where a 10 centimeter plant would have been. So we're going to go ahead and put that here, 10, even though there's not data for it. And we always want to make sure that we have our hash marks about the same distance apart. So there's 11, 12, 13, 14, and then there's 15. Okay, and I think those are pretty close. You'll probably be a little bit neater than me. Now that we have our line plot set up, it's titled. We know that this from 0 to 9 is a lot longer than that. That's why we put those 2 marks like that there to remind ourselves that this is where our data starts, but we skipped a bunch of numbers. Now we can start putting our data on here. So we can say, all right, one kid had a 9 centimeter bean plant. 4 kids had 11 centimeter bean plants. Already I can tell that more kids had 11 centimeter bean plants than 9 centimeter bean plants. All right, 12, there were 6 here. And I'm just going to quickly put this data on so we can talk about it. 13, 7 kids had 13 centimeter plant. 5 kids had a 14 centimeter plant. And 3 kids had a 15 centimeter plant. All right, so there would be our line plot then for this data. Okay, let's look at some of this now. Which bean plant height occurred most often? Well, it would be the tallest one, wouldn't it? So that's right, 13. 13 centimeters was the bean plant height that occurred most often. See if you can get this next one. What is the difference between the tallest and the shortest bean plant? Do you know what I would do to do that? I would take the height of the tallest plant, 15, and then the height of the shortest bean plant, which is 9, and I would subtract or count up. I would go 15 minus 9, or I could count up from 9 to 15. So the difference is 6, and if you count the spaces in between, 1, 2, 3, 4, 5, 6 centimeters, you can prove it that that's the difference between the two. How many students are in this science class? This might take us some time here. If every student had a plant, and every plant is shown on this graph, then every student is an X. So to figure out the number of kids in this class, we would have to do 1 plus 4 plus 6 plus 7 plus 5 plus 3. How many students are in this class? We would add all of those numbers up together. Are there any measurements outside the main grouping? And what that means is most of the measurements are all clumped together here. But this one here is kind of away from the others. It's kind of outside of the main grouping. And why do we think that is? Why might this happen? Well, there's a lot of reasons why this might happen. It could have been a plant that didn't want to grow as well as the others. It could have been a kid that maybe was absent and didn't get a chance to water their plant as much as the others. It could have been a kid that wasn't maybe as accurate at measuring, and so maybe they measured it wrong. There's a lot of reasons why this one might be different from these. And what do you think would happen to this data if we watered the plants and we fed the plants and we came back in 5 days and we measured them all again? That's the most interesting one. I wonder if all this data, since all of these plants would get taller, if all of these numbers would all have to shift down this number line to bigger numbers. There's so many interesting things you can think about and questions you can ask and answer when you are looking at data and trying to figure things out. Those kinds of questions are where we draw conclusions, the kinds of things that we figure out once we can look at the data. So that's another part of today's lesson. You're going to be drawing some conclusions. All right. And I want you to just stick with some of these questions and just keep thinking, and I know you'll get them. All right. So have a great math lesson today. See ya.